Number 16 just wants us to compare the quantity in column A with the quantity in column B. So we know in column A, the probability of A given B just means the probability of both events, so the probability of A and B, divided by the probability of what you're given, so divided by the probability of B. Now in column B, following the same formula, probability of B given A just means the probability of both events, again, the probability of B and A, which, keep in mind, these two things mean the same exact thing. It doesn't matter whether you say A and B or B and A, it's the same thing. And again, we're going to divide that by the probability of what's given, so the probability of A. All right, so all you have to do is just look above and see what they give you. So it says the probability of A and B is 0.27, so that's actually going to be our numerator for both of these. And the probability of B is 0.4, whereas the probability of A is 0.7. Okay, so you can divide these. This you get 0.675, and these you get 0.386. So we can clearly see that the quantity in column A is clearly greater. So that is choice A. Number 17 just wants to know what's true about the following three functions. All right, and we're talking about odd and even here. So now, just to remind you, an even function is a function that's symmetric with respect to the y-axis. So for example, if you were to fold along the y-axis, one half of the graph would fold directly on top of the other half of the graph. Odd just means it's symmetric with respect to the origin. So if something's, symmetric with respect to the origin, it just means if you flip it upside down, it will look exactly the same. So flip upside down. Okay, so let's take a look at the first function. The first function, f of x, they just gave us the equation. So what I did was I just went to y equals in my calculator and graphed it. And this is what I got. Now, you could see that this right here, this is symmetric with respect to the origin. If you flip this upside down, it will look exactly the same. So we could say that this one here is odd, okay? O for odd, O for origin. All right, g of x, all they wanted you to do was take f of x, which is this, and subtract 2 from it. So all that's going to happen is f of x is going to shift down 2 units. Or you could plug it in this equation in your calculator and see what happens. But if you shift this down 2 units, if you take this function and flip it upside down, it's not going to look the same. Here, I'll show you what happens, what it looks like when you flip it upside down. What you'll notice is that this portion of the graph that was now below the x-axis, right, is now above the x-axis. You can, to see if something's odd, when you flip it upside down, just take your actual paper and flip it upside down and see if it looks the same. All right, so anyway, this one's not odd, and it's definitely not even either, because if you fold along, going back to this function, if you fold along the y-axis, one half does not fit directly on top of the other half. So this one is going to be neither. And then finally, if we look at h of x, that picture is given to us, and we can clearly see that this one is symmetric with respect to the y-axis. If you were to fold along the y-axis, one half would fold directly on top of the other half. So we could say this one is even. Number 18 gives us a function, and what they want us to do is they want us to find the inverse of this function. Okay, inverse just means to switch the x and the y. Now keep in mind, another way of saying f of x is y equals, right? You can think about this as y equals. So if we're going to switch our x and our y in order to find the inverse, what we're going to do is we're going to make this y an x, so it's now going to say x equals, that's an x, and we're going to make this x a y. All right, and then all you have to do is just solve this equation for y. Now, in order to solve for y, I think what I'm going to do is I'm going to just get rid of these fractions. So if I want to get rid of these fractions right here, if I want to get rid of the denominators, I'm going to multiply both sides of the equation by the bigger number within these denominators. So I'm going to multiply both sides of the equation by 4. All right, so on the left side, that's just 4x. And on the right-hand side, when I multiply this by 4, well, 4 times 1 half of 4 is 2, so that becomes 2y. And then minus 4 times 3/4, what would happen is if you thought of this 4 as 4 over 1, the 4 on top would just cancel with the 4 on the bottom, leaving you with 3 over 1, which is just 3. Okay, so now to finish solving for y, I'm just going to add 3. So we'll have 4x plus 3 equals 2y, and then just divide both sides by 2. All right, so we're left with y equals, you can leave it as 4x plus 3 over 2 if you want, or we can individually just, divide these terms by 2. So since 4 divided by 2 is 2, this is going to become 2x. And let me actually write it over here, because you want to rewrite your answer having f inverse of x. So this becomes 2x, and then plus, well, when we divide the 3 by 2, I mean, that's going to be a decimal, so I'm going to leave it as a fraction. I'm going to leave it as 3/2. So this is one way you can write your answer. And if you wanted to just leave it, I'm just going to write or. If you wanted to leave it like you had it over here as 4x plus 3 over 2, you can do that as well. That's a 3, by the way. Number 19 wants us to algebraically determine the zeros of this function. Well, in order to do that, we first need to figure out what b is equal to. And we can use either one of these givens to help us solve for b. All right, I'm going to use the second one right here. This tells us that if we take -5 and substitute it in for all our x values, we should wind up with a result of 0. So what I'm going to do is I'm going to replace all these x's with -5. I'm going to replace this side of the equation with a 0. So it looks like this. Now from here, all we have to do is just solve this for b. So we can say that 0 is equal to, well, 6 times -5 cubed is equal to -750. And then since -5 squared is 25, we'll have plus 25b. And -52 times -5 is positive 260. And let's bring down the plus 15. All right, so from here, let's just combine all of the like terms. If I combine all of these numbers, that'll give me -475. And let's bring down the 25b. And then to finish solving, just add 475 to both sides. And then divide by the 25 that's in front of the b. Okay, so we wind up getting b equals 19. So if we go back to our original equation, or original function here, what we can do is we can replace this b with a 19. So it'll look just like this. All right, so we have our function here with the b being replaced with the 19. And we're going to use, what we want to do is, in order to find the zeros, we're going to need to factor this. Now, by looking at it, even if you tried to group it, the factors aren't going to come right out to you. But we can use this right here. If we know that z of -5 is equal to 0, what that's telling us is that x equals -5 is a 0. And if we know that x equals -5 is a 0, then x plus 5 is a factor. So if we take this expression and divide it by its factor of x plus 5, then whatever we're left with here should be another factor. All right, so let's do long division. So we want to say, what do we multiply x by to give us 6x cubed? Well, we're going to multiply it by 6x squared. So if we take the 6x squared and multiply it to the x and then to the 5, we would wind up getting, so 6x squared times x is 6x cubed, and then 6x squared times 5 would be positive 30x squared. Now because we're going to subtract, we have to change our sign. So this is going to become a minus and a minus. All right, these will cancel off, and 19x squared plus, minus 30x squared would be negative 11x squared. Now let's bring down the next term. All right, so let's repeat the process. What do we have to multiply x by to give us negative 11x squared? Well, negative 11x. So then negative 11x times x is negative 11x squared, and negative 11x times 5 would be negative 55x. So again, we're going to be subtracting, so we're going to change our signs. So these will cancel, and negative 52x plus 55x is 3x. And then bring down your plus 15. All right, and then finally, we need to multiply this x by 3 in order to get a 3x. So I'm going to put a plus 3 up here. So then 3 times x is 3x. And then 3 times 5 is 15. And when we change our signs in order to subtract, everything cancels. So there is no remainder, which is exactly what we wanted because, if there's no remainder, what it tells us is that this is another factor of this expression. Okay, so at this point, if we want to find the zeros, let's just take the factor of x plus 5 we know, and the factor of 6x squared minus 11x plus 3, and let's set that equal to 0. Now this can factor further. So let's go ahead and do that. So this is going to be factor by grouping, so we have to come up with two numbers that multiply to 18 and add to negative 11. Now, what we're going to do is we're going to bring down the 6x squared. We're going to leave a big space and bring down the plus 3. But two numbers that multiply to 18 and add to negative 11 are negative 9 and negative 2. So we're going to split this middle term up into a negative 9x and a negative 2x. All right, and then let me just bring all this down. Okay, so now from here we can do our grouping. All right, I could pull out a 3x out of the first two terms, which leaves me with 2x minus 3. And then to be left with a 2x minus 3 out of the next two terms, I'd have to factor out a negative 1. So when I do, negative 2x divided by negative 1 is positive 2x. And then positive 3 divided by negative 1 would be negative 3. Okay, and we wanted these two factors right here. We wanted those to match up. All right, so I'm going to bring down the 2x minus 3 as one of my factor. And then this 3x minus 1, I group those together to create my other factor. Now, I don't want to forget about that x plus 5 that we had in the beginning here. So let's start bringing that down. And now that I have this fully factored, let's make a t-chart and solve. So we wind up with x equals negative 5. Here, if you just take the 3x minus 1 and set it equal to 0, you can add 1 to both sides and then divide by 3 to give you x equals 1/3. That's another factor. And then if we take our 2x minus 3 and set that equal to 0, we can add 3 to both sides and then divide by 2 to give us x equals 3/2. So these right here are our zeros. And if you want to check, take that original function that they gave us, just, replacing the b with a 19, and plug it in your calculator and graph. And look at where the graph intersects the x-axis. Okay, you can find your zeros. And you'll see that they're at these three values. In number 20, Nick has 3 different investment options to choose from. All right, he has $8,000 that he wants to invest. Now, in option A, it will pay him 2.4% interest compounded annually. So because it's being compounded once a year, we can just use our basic exponential growth formula here. All right, so if we want to make a function for this, let's just say, since they want us to write the function in terms of n years, let's say for this one, we'll say a of n is equal to, the initial value that he's investing is $8,000. Since the rate is 2.4%, we could write that as 0.024. And we're going to raise that to the n power because they want it in terms of n. All right, so with option B, it will pay him 2.375% compounded quarterly. So since this is compounded more than once a year, we're going to use our compound interest formula. All right, so I'm going to call this one, for option B, we'll call it B of n. So B of n is going to be equal to, he's still investing $8,000. This time the rate is 2.375%. So we could write that as 0.02375. And n stands for the number of times a year that it's being compounded, that it's collecting interest. So it compounded quarterly. Quarterly means 4 times a year. So I'm going to replace the n with a 4. So we'll replace this n up here as well with a 4. And t, they want us to call the time. They want us to use that in terms of n, so we're going to put an n right there. And then finally, option C will pay him 2.35% compounded continuously. So whenever something's compounded continuously, we can use A equals PE to the RT power. All right, I'm going to call this one C of N. And again, he's investing $8,000. I'm going to multiply that by E. And this time our rate is 2.35%. So we could write that as 0.0235. And again, the time is going to be in terms of N. So part B just wants to know which account will earn the most money for Nick over the next 10 years. So all we're going to do is just take each of these functions and replace these n's right here with a 10. All right, so now you just have to plug each of these into your calculator, and we'll see for option A, you wind up getting, I'm just going to round to the nearest cent here, $10,141.20. For option B, you will get $10,137.48. And option C is even lower. You wind up getting $10,119.27. So option A is our answer here. This is the one in which he will have the most money after 10 years. All right, so letter C just wants us to determine algebraically how long it will take for option B to double Nick's initial investment. All right, well, if he invested $8,000 and we want it to double, we want to see how long it's going to take to, have $16,000 in the account. So I'm going to replace this side of the equation with a 16,000. And then we could just bring everything else down. Now, you know what I'm going to do? You can plug, if you want, you can plug this into your calculator, and you can write it as a decimal. That's up to you. But if you do, you wind up with 1.0059375. Okay? And we'll raise that to the 4n power. All right, so what we want to do is we want to try to get this term that's being raised to the power with our variable on it by itself. So I want to get rid of this 8,000. So in order to do that, we just divide both sides by 8,000. So 16,000 divided by 8,000 is 2. And then I can just bring down the right-hand side of the equation. Okay, now in order to get this variable out of our exponent spot, we're going to need to put the word log in front of both sides of the equation. Because when we do that, we can take this exponent, right? The power rule says you can take this exponent and bring it to the front of the word log. So we're going to have log of 2 equals 4 times n times log of, I'm just going to put it in a parenthesis, although you don't need it, this number right here. All right, so to get the n by itself, let's first divide by by log of this value on both sides of the equation. And you can just plug that right into your calculator. Okay, so when you do, I wound up with approximately 117.0868. And then to get the n by itself, just divide both sides by 4. And I do wind up with n being equal to about 29.2717. And they want it to the nearest year, so that would be 29 years. And make sure you label your units. Make sure you label years there. All right, and finally, letter D just wants you to determine how long it will take for option C to increase Nick's initial investment by $4,000. So if his initial investment was $8,000, if we want to increase this by $4,000, we want to see how long it's going to take to grow to $8,000 plus $4,000, so to $12,000. So I'm going to replace the left-hand side of the equation with a 12,000, and then you can just bring down the right-hand side of the equation. Okay, so we're trying to get the e to this power by itself. So in order to get rid of the 8,000, let's just divide both sides by 8,000. And then 12,000 divided by 8,000 is just 1.5. Okay, now, in order to get rid of the e, we can put an ln in front of both sides of the equation. So what happens is, we're going to be left with ln of 1.5 equals, really just this exponent here now drops down. It becomes 0.0235 to the n power. And to finish solving for n, just divide both sides by the number that's in front of the n. and I wind up with approximately 17.2538, but they want it, let's see, to the nearest tenth of a year. So to the nearest tenth of a year, we would wind up with 17.3 years. And again, remember to always label your units. Make sure to put the word, years right there.